All right, y'all. So we are on problem number 5. We should factor this guy. So first thing I notice is that we have to factor out the x cubed plus x squared. So x cubed and x squared are both divisible by x, but they're also both divisible by x squared. So we factor that out. X cubed divided by x squared, right, is x. So that goes here. And then x squared divided by x squared is 1. So the 1 goes inside here. We divide it. So x squared minus 4. This is a straightforward problem of x squared minus b squared, right? This is a difference of squares. And if you remember, a squared minus b squared is simply a plus b times a minus b. Another way you can do it is simply to say what two numbers multiply to get -4 that adds up to 0. Those two numbers must be 2 and -2. And so there we have it. Nothing cancels out, so there are no holes. So to find the x-intercept, we set y is equal to 0. In this case, we set the numerator equal to 0. Because when you set 0 is equal to x squared times x plus 1 all over the denominator, right? If we cross multiply, it just goes away. So a faster way of doing it is simply to say 0 is equal to x squared times x plus 1. So set the numerator equal to 0. There are two factors, so there should be two zeros, right? But notice that this is x squared. So we set that equal to 0. We take the square root of both sides. So one answer is x is equal to 0. The second solution should be x plus 1 is equal to 0. And we subtract 1 from both sides. So x is equal to -1. So let's plot our two x-intercepts. One is at 0. One is at -1. Very interesting. They're very close together. So the y-intercept obviously should be 0, 0 as well. And since there's only one, that is your answer. 0, 0. You could also simply just say g of 0 is 0 plus 0 over 0 minus 4. All of these just become 0. So 0 plus 0 is just 0. Then 0 minus 4 is -4. And 0 divided by -4 is just 0. But we already knew that. To find the vertical asymptote, we take a look at our fraction, right? Take a look at this guy. Our denominator is x plus 2 times x minus 2. So we set them equal to 0. Set each factor equal to 0. And then solve. So one solution should be -2. Set this other factor equal to 0. And add 2 to both sides. So our two vertical asymptotes should be at -2. So let's draw those. And +2. So very interesting. It looks like there is no horizontal asymptote because the degree here of the numerator is 3, but the degree of our denominator is 2. When the degree of your numerator is exactly 1 greater than the degree of our denominator, we have what we call a slant asymptote. So unfortunately, class, we have to do the long division here. And to do the long division, we take a look at the OG function. We take a look at let me fix this real quick. We take a look at this function. We need to take x squared minus 4, put that on the left. And on the right, we put x cubed plus x squared. And I like to put placeholders here for 0x and 0. I personally like to do that. I suggest that you do that as well to see what's up, right? So x cubed divided by x squared, right, is simply x. So that goes here, that goes on top. And you take x and you multiply to x squared minus 4. And this is where it gets kind of trippy. X times x squared is x cubed. X times negative 4 is negative 4x. So we subtract x cubed, I line it up, and then I skip this one because there's no 0x squared, see, there's no 0x squared. I'll put the negative 4x here. So I put like a 0x squared so I know that's a placeholder. And then I just subtract them. This goes away. X squared minus 0 is going to be positive x squared. 0x minus negative 4x is positive 4x, right? And then I do it again. So what I do is I look at x squared, I divide it by x squared, that's just 1. So therefore, it should be a plus 1 on top. So this is my slant asymptote. I technically can just stop here, right? But if you wanted to continue, this is what it's going to look like. It's going to be minus 1 times x squared minus 4. That's like saying x squared minus 4. So that's x squared. You skip this because there's missing an x, and you drop down to 0. So that's going to be, I should have dropped down to 0 first. Minus 4. Right? So we subtract, and we're left with 4x minus 0x is 4x, and 0 minus negative 4 is plus 4. So the remainder was not very helpful, right? We didn't really need it, the remainder. But this remainder tells us that it crosses our asymptote. So the remainder is nice because if you take the remainder where it crosses, right, and you set it equal to 0, and you solve for it, you get 4x is equal to negative 4, x is equal to negative 1. So it crosses at negative 1, right? So what we care about, though, is the slant asymptote. So this is a slant asymptote at y is equal to x plus 1. So let's do that in red. So the slant asymptote says we have a y-intercept of 1, and the slope is 1. So we go up 1 over 1, up 1 over 1. So it's just a diagonal, really. That looks like that. Right, so we make a dotted line. And so we have something like this. Afterwards, you want to use a calculator, and you want to make some kind of like sign chart, right? So the sign chart is something that looks like this. So you might be wondering what goes into the sign chart. The numbers are, first, think about our asymptotes. They are at negative 2 and at 2, right? So we should make negative 2 and 2 as part of our sign chart. But then we also have an x-intercept at 0 and at negative 1. So let's put them in order. Let me just fix this. Let's put several more tick marks. So we have negative 1, 0, and 2. So these are my critical values, right? And we know that there are vertical asymptotes at negative 2 and at 2. And these are just x-intercepts. So if you care about the behavior near vertical asymptotes, then let's see what happens when we plug in numbers that are to the left of negative 2, right? So let's say I plug in negative 3. So you take negative 3, you plug it in, right? And you see what I get. So just fast forward, if you plug in negative 3, you should get like negative 3.6, which is a negative number, right? So that means that anything to the left of negative 2 is negative. So negative 3 comma negative 3.6 is here. So it looks something like that. It's below this line, right? So let's fix that. Bam, bam, bam. All right. So now we plug in a number that's between negative 2 and negative 1. So let's say you plug in like negative 1.5, right? So if you do that properly, it should be a positive number. So use your calculator, plug it in, it's positive. So it's above the x-axis. Then you plug in the number between -1 and 0. It's going to be negative. So it goes down, but also goes back up. Right? And then from 0, you realize that, oh, this is also going to be negative. Now, normally, it should go negative, positive, right? But the reason why this becomes a negative and a negative is because this is a double root, right? So at 0, there is a double root because of this guy. It's a double root. And then at 2, let me just finish that. So it goes down like that. And at 2, this is just positive again. So that means it looks something like that, right? You could, if you have a calculator, you can plug in more values. So for instance, you plug in like -5, you should get -4.8. If you plug in 1, you get -2/3. You plug in 3, you get like 7.2, it looks like, yeah. But you get to use the calculator so you can plug those values in to see like if it's going to be positive or negative, right? So you see how when I plug in -5, I get a negative, right? -4.8. If I plug in -3, I get -3.6, right? If I plug in a 1, when I plug in 1, right, it's like -2/3, so it's negative. If I plug in 3, right, it was like 7.2, so I was actually kind of close. 7.2 is like right there-ish. All right, and we are done.